Okay, so let's start today's lesson. And let me go back to the top. And before I start, let's do a little recap on what happened in the last lesson. So give me some words or some things you remember from the last lesson. Pop it in the chat or let me know. So Q1, we talked about something called Q1, or the first quartile or the lower quartile. We spoke about the standard deviation, and we used our calculators quite a lot. We spoke about Q3, which is the upper quartile. We spoke about Q2, which is the median. Okay, now the last lesson was really about summarizing. Oh, we did the IQR, the interquartile range, and we also did the semi-interquartile range. So the last lesson was all about basically how to measure how spread out a data set is. So that was lesson 2 in the series. Lesson 1 was all about where is the middle of the data. And we spoke about measures of central tendency. So that was lesson 1. Okay. Now, when we found the Q1, Q3, and Q2, we used these things called the position formulas, and they helped us calculate the position of each of these things in a list before we went and actually found the value of Q1, Q2, and Q3. And the formulas we used were these ones. What does the N in the formula stand for or do? What does this N represent in the position formula? Who would like to let me know? Okay, so Kelly, the number of items in the list or the number of terms in the data set. Flamello, I absolutely agree. So if we had a data set with 12 items in it, N would be 12. Okay, awesome. So that was the last lesson. So what about today? What's a little bit new? Well, we're going to talk about something called percentiles to start with. Now, a percentile is very close to the idea of a quartile. It's just one little bit of difference. So if I say to you, I want to find the 80th percentile. The 80th percentile is 80% of the way through the data, and we call that P80. Now, to find P80, I would use the position formula. Position P80 is 80 over 100 times n plus 1. Now, when I find the position, I might get some decimal values. And if I get some decimal values with percentiles, we do not average out between the two nearest ones. We round off. We round off the position to the nearest position. Okay? Now, that is a little bit different to quartiles, where if we got a position value that had a fraction, we averaged out between the two nearest positions. So let's see how this works. Let's take this data set here. And it's already arranged from smallest to biggest. So to find P80, I'm going to first find the position of P80. And I'm going to go 80 over 100 times n plus 1. Now, I don't know what n is, so let me look at my data set and count. 1, 2, 3, 8, 9, 10, 11. And it's halfway, which means n must be 22. So n is 22. So now, if I want to find the position, I'm going to have to work this out. And I suspect it's going to be a decimal. Tell me in the chat what decimal value you get for the position of P80. what position do you get for the position of P80? And give me the decimal values as well. Okay, so lots of students are telling me they get 18.4. Now, with percentiles, we do not average out between the 18th and the 19th position. We say, what is the closest to this? And the closest one, if I round off, is going to be the 18th position. So I look for the 18th position in the list, and that will be P80. What is P80 using this information you have just worked out? So you know it's the 18th position. What is its value going to be? Remember, that was the 11th position. So 12, 13, 14, 15, 16, 17, 18. So for me, the value of P80 is going to be 27. And what that means is 80% of the data is below 27 and 20% of the data is above 27. Okay, so percentiles, the only real difference is that with the position formula, we round off, and the formula itself is very similar to what we were using before. So just to make sure you got this, I want you to find me the value of P65, or what we would call the 65th percentile for this data set. What is the 65th percentile? And I want you to try and use what's already on the screen to help you. When you've got your answer, just put it in the chat. So I first of all have to see how this works to n+1. What is my decimal position going to be? I see lots of you are saying 25, but it's before we get there. Are we happy to get 14.95? Now, if we round that off, the nearest one is going to be the 15th position. And then 15th position is going to be 11, 12, 13, 14, 15. 12, 13, 14, 15. And so my value is going to be 25 for P65. Okay, give me a thumbs up if you feel like you understand how percentiles work. Give me a thumbs down if you're still a little bit unsure or you want me to do another example. It's not too difficult. It's just I have seen this in questions, and it's important you understand the sort of minor difference. Okay. Awesome, awesome, awesome. Okay, well then, let's move on to the main part of tonight, which is the 5-number summary and the box and whisker plot. And what a 5-number summary consists of is just the lowest value in the data set. Then it consists of Q1, Q2, Q3, and the max. So let me even write it in words. So there's the min and the max. And you have to find Q1, Q2, and Q3. And then what you do is you take these values and you put them into a graph. And you have below the graph a number line. And then what you do is you have a box that goes between the value of Q1 and the value of Q3. And then you have a line inside this box, which is in line with Q2, which is the median. And then you have a whisker that goes up to the max value and a whisker that goes down to the min value. And normally you wouldn't actually write values on the box and whisker. The numbers below would show you what the actual values are for the items. Okay, so I'm going to do an example with you now, but give me a thumbs up if you've seen a box and whisker plot before. Give me a thumbs down if you've never seen a box and whisker plot. It's helpful for me to know as I go about explaining. Okay. So let us look at an example where we have two different communities that we're comparing. Whenever we do a box and whisker plot, often a box and whisker plot is very useful for comparing two different populations. So what I have here is I have a class, a grade 10 class made up of 26 students. But the 26 students are split into girls and boys. And what they've done is they've taken the heights of boys and girls, and they've also written them from smallest to biggest, so they're ranked. Now, what I want you to do is let's do girls first. I want you to find me the 5-number summary for girls. So that will consist of finding the minimum, finding Q1, Q2, Q3, and max. So go ahead now and find these 5 values for me. And remember, you need to look at only the set that relates to girls. I want you to do that by yourself. And then if you are unsure, I want you to raise a hand or ask a question. So over to you guys. I can zoom in. Yep. That is the magic of being live and online. Does that help, Nompido? Pleasure. It feels like the min and max are quite easy in some ways. What is N going to be for girls? What is N going to be for girls? It's going to be 13. Well done. Because it's not 26, because obviously you can see these sets are equal. So then that's going to be the 7th. What is that going to be? 3.5. Okay, now be careful because we've just done percentiles. Remember, quartiles work differently. If you get a fractional value, then you have to average out between the two nearest values. And that is different. Quartiles work differently than percentiles. And this shouldn't be Q1, this should be 150 for the min. So let's have a look. 3.5 is here. 5, 6, 7. Q2. So what is my Q1? It's going to be halfway between these two, which is 154. My Q2 falls perfectly on 160, and my Q3 is going to be 165. So what you've done is you've found the 5-number summary for girls. The 5-number summary for girls is just 150, 154, 160, 165, 170. And what I would like you to do now is I'd like you to find the 5-number summary for boys. Okay, so go ahead and find me the 5-number summary for boys. If there's any questions about how I found for girls, please put your hand up and I will attend. But for now, I'm seeing that things are going okay, and so we can Now, what I've just noticed is that because the N is the same for boys and girls, it's both 13, the working out that I need to do for position formulas is going to be the same. I don't need to do the position calculations again because the N value is still going to be 13. So in some ways, I can save myself some work by just reusing the positions. Give me a thumbs up if you understand what I mean by that. Like, you understand why you don't have to redo the whole thing again from scratch. You can see the pattern. Okay. So let's go and look. 3.5. 1, 2, 3. So it's going to be here. And then 7, 4, 5, 6, 7. So that's going to be Q2. And then 7, that's 8, 9, 10. So here is Q3. So what I get is Q1 is halfway between 151 and 157. And what I would do is I would add them together and divide by 2. And you should get 154. For Q2, you should get 160. And for Q3, you should get 180. And so for boys, your 5-number summary is going to look like that. So that's for boys, and that was for girls. And Paul asks, sir, whilst plotting the box and whisker, what happens if the max and Q3 values are the same? And Paul, what happens, and we're going to do this now, is that there is no whisker on the top, basically. Okay, now, before I go on to the box and whisker, I want to know what is the interquartile range for girls and what is the interquartile range for boys. So the IQR, or the middle 50% of the data, I want to know what is the IQR for girls, what is the IQR for boys. This is the middle 50% of data. You can kind of see it visually here, because remember, this is Q3 and this is Q1. What do we get? So for girls, it's going to be 165. So we should get 11. I should have done that in green, but. And for boys, 180 minus 154, which is 26. So what do we notice about the interquartile range for boys and girls? What are some of the things we could talk about if we had to describe the differences? I think the middle 50% of girls are within 11 centimeters of each other, whereas the middle 50% of boys are within 26 centimeters of each other. Okay, so I think that what you can say is that the girls' heights are closer together. You know, essentially they are packed more closely together and less spread out than the boys. The boys have a greater range of the middle 50% of the data. They also have a greater range, full stop. But we'll see that in the box and whisker. Okay, now, how do we actually draw the box and whisker plot? It's actually not so bad. And we might do some more after the break, but let's start by having a number line. So what I do is to draw the box and whisker plot, I go, what's the smallest value I need? And in this situation, the smallest value I can see is 140. And I'm not going to write every number because it would take too long, but I'm going to go for 2, 4, 6, 8, 10, and that's 150. And then 2, 4, 6, 8, 10, that's 160. 2, 4, 6, 8, 10, 170. Oh, I lost my place. 10, 170, which is here. 2, 4, 6, 8, 10, 180. Okay, so this is the range over which the data is going to be, you know, in play. And so I'm going to draw the boys box and whisker plot first, and then I'm going to ask you to draw the girls. So for boys, and this is what Paul was asking about, is the lowest, well, let's do the box first. The box is from 154 to 180. So where was that? 2, 4, 6, 8, 10. So 154 would be here, and 180 is all the way up here. And so the box is just going to look like that. So I've done these two. The median is at 160. So the median is over here. And then the distance down to the lowest value goes down to 140. And so the whisker goes down to 140 here. However, it can't go further up to 180. So the whisker is sitting on 180 and it's over there. So that's what boys take care of. Now, what I want is I want you guys to draw the girls' box and whisker plot on your own set of axes. And then after that, we're going to take a break. So draw for me box and whisker plot for girls, but on the same set of axes, so just above this. So like 154 would be here still, and I'll just put here B for boys, so you know this is the boys box and whisker, and then green for girls. So go ahead and draw that for me now. So you can use a dot import. It's more common in South Africa to see the lines at the end here, the whiskers, but it's not wrong to put the dots there. But my preference is the whiskers. But technically, no, there's no, yeah, it's fine. I feel like the dots don't stand out as much. That's why I like the whiskers. So I just like them. So it's very clear to visually see. But I know in America, they generally use dots as well. Because sometimes you can say it gets too cluttered with the lines, I suppose. All right, 154, 165 would be, was that 161, 164, so 165 would be there, but that is the, so that's going to be for girls, that's the interquartile range or the box. And 160 is going to be there. And then it will have whiskers going up, so 170. And then it will have whisker going down like that, which is 150. So you can see how different, you can visually see how the heights of girls are definitely less spread out, even in the middle 50%, and in the whole range. You can definitely see that girls' heights are fitting into a smaller space. Give me a thumbs up if you feel reasonably confident with box and whisker plots. Give me a thumbs down if you feel a bit unsure. Okay, we'll do one more after the break, but then after that we'll move on, because I don't think it's too hard, but it's nice to do one or two proper examples. Cool. Okay, then I want everyone on their feet, and I want to do some offensive. I'll come to your question after the break. I do see your hand. Let's do some exercise, because we're humans and we need oxygen and blood and all these things that help us. So turn cameras on. Let us see each other and feel that we are connected. And let's start by swinging our arms a little bit. So actually, let's do big circles. And look out ahead of yourself. And you can even look away so your eyes get a break. Focus on something far away. And then you can go to smaller circles as you're doing that. And then I want you to change direction with your arms, small circles. And then change the position of your eyes so that you're looking somewhere different in the room. Your arms are still moving. Okay, then I want you to start twisting a little bit. Initially rotate just a little bit. And then as you are feeling more loose, you can rotate like this. Okay, then let's roll our shoulders. Roll the shoulders back nice and look out in front. And then roll the shoulders forward. And then stretch your arm across yourself, grab your opposite shoulder, and you can stretch. And then switch up to the side. Okay. Then a tricep stretch. And then switch to the other side. And then loosen up your arms. Just swing them out like this. Let's take 3 deep breaths. Yeah, so hopefully you feel a bit looser, you have a bit of oxygen. Let's get the blood pumping. We're going to do 15 jumping jacks, and we'll start in 3, 2, 1. Let's go. 2, 3, 4, 6, 7, 8, 9, 10, 15. And the warm-up is in the brain break is complete. And while your heart rates are coming down, I want to see, can you find me the missing value at the top of the pyramid? And yeah, oh, my heart rate is pumping. Do you feel a bit relaxed? Do you feel a bit like, should a box and whisker diagram have a scale? In Corsi, yes, that traditionally is. I have seen sometimes people write the values on the box, but it's generally preferred to have a number line below it so you can compare multiple box and whiskers. Okay, Khalid, how did you get there? How did you get 216? What was your trick? Or what was the insight that you realized? Okay, everyone seems to have got 216. So I think you might have seen 1 times 2 gives you 2. 2 times 3 gives you 6. 3 times 1 gives you 3. 2 times 6 gives you 12. So clearly we must be multiplying. And so to get the answer, you go 12 times 18, which will indeed give you 216. And so tonight's puzzle, it seems as if you guys were on it, chop, chop. So well done to you. Okay. Fancy, what was your question? Let me come to you. What was your question before we carry on in the lesson? Okay, I don't know if you can hear me. All right. So you can unmute yourself, Offense, if you want. While I'm taking that question, I want everyone to try and draw a box and whisker plot for me on this data. Yes, Offense, what's your question?
So will I lose marks if I don't label the whisker box?
If you don't label the box and whisker?
Yes.
Okay. You don't have, okay. Normally, if you have a line below, a scale below, then the numbers come from the scale, right? So if you look at this, what this is saying is that that value is 521. So you don't have to write your values if the scale is there, because that's the point. If there is no scale below, then it's a good idea to write your numbers so you know what each value is. But 90% of the time, you're going to see one with the number line below it. Okay. However, you guys have to work out the 5-number summary here first before you can draw your box and whisker. So I want everyone to draw a 5-number summary and a box and whisker plot for me. And I'm largely going to let you do it by yourself, but I will answer questions if there are questions. Offense, did that answer your question? I see your hand is up. Let me just unmute you again.
Yes, I understand, sir. Thank you.
Perfect. Glad to help. So this scale here is to help you guys, eh? So you can see what the scale is, but you're going to have to do some working out first. So it seems like the Q1, or the lower quartile, is in the 4th position, so it's 507. Q2, or the median, is in the 8th position. So that is there. And Q3 is in the 12th position. Yeah, Yazi, I agree with you. We're getting the same values. Now, once you've got your 5-number summary, I want you to draw the box and whisker plot for me using the scale that I have on the screen here. So 507 should be here. Okay, so I've drawn my box and whisker plot, and I want to ask you, if you feel comfortable and you were able to draw this, let me know in the chat with a thumbs up. If you felt rushed or if you felt confused, let me know in the chat with a thumbs down. Again, be honest, because I don't always have your body language, and so I have to go on the thumbs. Okay, so okay, felt rushed. Okay. Cool. No, that's good. That's helpful information for me to know. Okay. So a bit more time. Cool. Thanks for letting me know. All right. Now, I'm going to give you, there's going to be probably a chance for one more tonight. So I don't want to, yeah, I think also, yeah, cool. Thanks for the information in the chat. I do want to ask you, if you look at the top 50% of the data, the top 50% of the data, you can see it going from here up to here. And if you look below 510, you see the lower 50% of the data. What do you notice the difference is between the blue squiggle and the green, or the top 50% and the bottom 50% of the data? How would you describe that difference? So some of you know the fancy words, but I think the top 50% of the data is more spread out. So like if you look at the top 50%, okay, let me just get this again. So the top 50% goes between 510 and 526, whereas the bottom 50% fits in the space between 510 and 503. So it's almost like this part is spread out and this part is a bit more squashed together. Now, the technical word we have for when the one side is more spread out than the other is skewed, and we say this data set is skewed to the right, or you can say it is positively skewed. And the reason it's positively skewed is that it's spread out in the direction of to the positive side. So I just want to start by naming, because sometimes you have to describe what you see, and this distribution is said to be skewed to the right or positively skewed because of the fact that it's more spread out in the top 50% than the lower 50%. Also, the other thing I want to point out is, can you see how much more spread out the top 25% of the data is than the 25% over here? You can see how the top 25% is the most spread out of all the data. Okay. So that's just a brief description of how you recognize whether a data is skewed or not. Let's do a couple of multiple choice questions, and then I'll ask some more skewed questions. So, can you answer this multiple choice question for me? So, interquartile range is that, and we know this is Q3 and this is Q1. So it should be that one. Okay, that's looking good to me. What if I asked you this question about a box and whisker plot? What do you think the correct answer is here? A couple of different answers coming in. So this is a combo of range and IQR. Range in this one will be 18 minus 4, which is 14. And IQR should be 15.5 minus 5.5, which is 10. So notice how the range goes from the smaller, well, that's min and that is max. So 18 minus 4. Whereas IQR is this one over here, it's the box, 15.5 minus 5.5, which is down there. So the correct answer is B. Okay, what about this one? Which combo is the correct median, range, and interquartile range? So the median has to be 6.5 because the median is sitting here. So I can cross that out straight away. The range has to be 14 minus 0, so 14, so that's gone. And then the interquartile range has to be 12 minus 2, which is 10, and 6.5, 14, and so D is going to be the correct answer there. Okay, so you can tell how for box and whisker plots, you can just use the number line, but you need to know what each of these lines represents. Here's a bonus question. How would you describe the skewness of this data in this data set? How would you describe the distribution of the data, or you could say the skewness of the data for this particular data set? How would you describe the skewness or the distribution? Keep those answers coming. Keep them coming. So because the top 50% of the data seems to be more spread out, it's not as spread out as before, but you can see that the top 50% is more spread out. And so we would say the data is skewed to the right or has a positive skew. Okay. And so that's just something to watch out for. Cool. We're on a roll. Let's see if I can squeeze in. That's another one here. Okay. Here are two box and whisker plots comparing the weights of boys and girls. So in Paul, you can use, you would look at a combination of the both. Whiskers can be very helpful because they tend to stand out. So why don't we do this example? Tell me the skewness of the distribution of the weight of boys. So tell me what you think about boys. What is the skewness of the data for boys? And what is the skewness or how would you describe the distribution of the data for girls? Looking at the data here. So okay, so Zama, I agree with you that for boys, it's negatively skewed or skewed to the left. What about for girls? Okay, Isa, what is your question? Go ahead.
Hi, sir.
Hey.
I just wanted to ask for the skewedness.
Say that again, for the skewness.
Do you look at the box or the whisker?
Okay, I think what I would do is I would look at the top 50% and the bottom 50%. So I'd look at both, to be honest. Now, the whiskers can be very helpful, right? But in reality, you want to look at the bottom 50% and the top 50%. And so you look at a combination of both of them, would be my answer. But the whiskers can be helpful. I mean, the whiskers, there's no doubt the whiskers here would have given you the right answer. But I think the safest way to do it is just to look at the top 50% and the bottom 50%. So it's a little bit of both. Does that help?
Yes, sir. Okay. Thank you.
Pleasure. Most of the time the whiskers are, but if, for example, what can happen is if the whiskers are about the same, then sometimes it can be helpful to look at this, a combination of both of them. Can a graph be equally skewed? Yes, Ukukle, that is a very good question. So Ukukle, if you have a situation like this, we would say the data is symmetrical or it doesn't have a skew, so no skew. And that would be if it looks, basically, if the whiskers look about the same on both sides, if the box is divided up roughly equally, and you get this pattern, we would say the data is symmetrical or is no skew. That is a fantastic question. Thank you, Ukukle, for helping us all learn something there. All right, I'm going to call it a night for tonight.